we'll talk about, because till now we talked about the indices, different parameters of a distribution system reliability. As I told you that advanced smart grid is possible only when the distribution system become reliable. Without having a wonderful, reliable distribution system, the ambitious goal of operating an advanced smart grid is next to impossible. So in this connection, what I wanted to highlight that the system reliability is a factor, and how can we improve the reliability? That is the goal, am I right? So probably if you ask me how to improve the reliability, I can say put parallel lines, put parallel generators, put N-2 contingency transformers, reduce the load, increase the generations. They are all general statements. But we'll see there are few areas that will help you to understand how the distribution network reliability can be improved. So enhancing the reliability of electrical distribution system is critical for ensuring a continuous and high quality power supply to end users. Various technologies and strategies are employed to achieve this goal. To start with, network reconfiguration. So now you have a network. Some of the consumers are not getting electricity because one line got failed. And what I have to do actually, I have to route that power actually through some other line. Okay, so I need to have a reconfiguration mechanism. So can I now say, having a network reconfiguration, the reliability is going to improve? Manmohan, is it okay? Yes. Reconfiguration will improve the reliability, number one. Number two, optimal placement of reclosures and switches. All right, either you reconfigure with switches, but you can also increase the number of actually switches and reclosures. Keep on opening. There are two radial lines. You switch it on, it become a loop. Weakly meshed networks can also be created by putting n number of switches. So to me, optimal placement of reclosures and switches are also part of reliability enhancement program. Third is distributed generation. If you put distributed generation, why the reliability will increase? By putting a distributed generation, the reliability is going to increase. Why? Why it has to increase?
Because there is no single point of failure.
No. If the main grid fails, if the main generator fails, if the transformer fails, still the distributed generator will be placed at low voltage network. So that can cater some of the loads. So having a distributed generation, 100% failure is next to impossible. Okay, that is one. Then we are going for the maintenance approaches. If you do a good maintenance approach, certainly the system will be more reliable. Energy storage system, yes, when you have renewable integrated, if you put a battery, then also the reliability is going to increase. Then microphasor measurement units, that is also certainly, why microphasor? You know what is phasor measurement equipments? In transmission system, we get the voltage and frequency and phasor stamping values at each and every moment, because what exactly happens, you in a smart grid environment, you measure a voltage at a particular point and then you take a control action, assuming that. But by the time I've taken a control action, the voltage might have changed there. So through a micro distribution network or a phasor unit, phasor measurement unit, if I measure that data, so probably it is as exact as possible. So the time delay can be reduced for some time. Okay, good. So moving to the next one, first of all, try to understand what is network reconfiguration. Fault isolation, for example, reconfiguration the network topology by opening or closing switches allow operators to isolate faulted sections while rerouting power through healthy feeders, minimizing customer outages. So what it says, if there is a fault being identified, I can disconnect that portion from the main supply system by putting a recloser or a switch. So fault isolation is possible through network reconfiguration. What about load balancing? That is also possible. One side is going to be, there are 5 feeders, all are actually unbalanced. By actually reconfiguration, I can balance the load. Next, automated restoration is also possible through switches. Okay, whenever there is a backup supply available to me, I can do restoring mechanism. So reduces due to network reconfiguration, reduces system average interruption duration index by up to 20% and system average interruption frequency index by 24%. So this could be a study from where actually might have taken this literature, the second one, which has given an idea how the reconfiguration helps the system reliability to improve. Now, second point, because we have discussed around 5 points, 5 to 6 points, we are discussing one by one. Optimal placement of recloser and switches. So whenever you talk about power outages due to fault, can have major economic and operational consequences. Recloser is automatic protective device, enhance reliability by quickly restoring power after temporary fault. Okay, so restoration is possible once actually the fault is being cleared. Now, could you see that there are few segments being identified in a 34 bus system? And the strategic placement of reclosers is essential because if that is the case, you can put a recloser at each and every bus and say, I can do magic. But again, a lot of cost is associated with that. Okay, so you have to optimize the switches in a network, similar to optimizing the capacitor, similar to optimizing putting the battery in a smart grid. All these things, single non-linear optimization study need to be carried out. So strategic placement of recloser is essential to minimize system average interruption duration index, AD, and system average interruption frequency index, SAFE. So we discussed about SAIDI and SAFE in our previous class. Heuristic optimizations are generally used for determining optimal recloser placements. Why heuristic? Because conventional and classical techniques will suffer with lot of actually optimization space, complexity, and hence such problems are being solved using uh, heuristic, especially genetic algorithms are being frequently used because all the switches you can say 0 and 1 because it is 1 and 0, no? So you can do mutation, you can do crossover and find a best solution for your optimal.
Reclosers are same as circuit breakers or different?
It is a switch basically. It is a switch. There is a line, it will just strip, that's all, or disconnect. So with this you will have one scenario, without this you will have. I mean, even you can say circuit breaker, no problem. It is switch only, yeah. So now, how do we do the optimal utilization or placement of reclosers? Minimize SAIDI and objective is minimize SAIDI and SAFE indices to enhance service continuity and reliability. The methodology which utilizes the IEEE 37 bus feeder as the test system. All data sourced from ENIL, Brazilian Electricity Regulatory Agency for realization. 4 scenarios with concentrated fault regions were designed for evaluation, the previous diagram, okay? Could you see this? These are the 4 regions. All right. The system is segmented into blocks by placement of reclosers. Each scenario simulates the system with 1 to 5 reclosers using both 20 and 50 degree volts. All right. So you could see the fault concentration will be with line 2, 9, 10, region 1. I mean, and then region 2 with 11, 12, 13, 24, 25. Region 3 with line 20, 21, 29, 31, 32. And region 4 is with 6, 14, 17, and 27. So there are 4 different scenarios can be created. This is what the bit of results. What it says that in case of first diagram, you can see that evolution of the SAIDI for each scenario based on the number of allocated reclosers and evolution of the SAFE for each scenario based on the number of allocated reclosers. So what we are doing basically, each scenario has a different color, please try to understand. So you can have the number of reclosures, quantity. You can have 1, 2, 3, if you keep on increasing the number of reclosures, you could see that actually the reliability indices, they are actually keep on changing from time to time, okay? And final conclusion, what they are saying that reclosures placed at feeder extremes, easy to isolate, best case for the reliability, that is highest SAIDI and safety improvement is possible in case of scenario one. Scenario two, they say early reclosure already isolates fault zone, slightly more complex than scenario one, which is very good performance. Scenario three, the first reclosure isolate distant extremities, consistent pattern with added reclosures, moderate performance, and the final one is the lowest improvement because difficult to isolate. Reclosures placed near central fault harder to manage. Now, what I will do, I'll now go and try to understand what is my scenario four. Scenario four means that is region four, central area of the feeder, line 6, 14, 17, 27. Moving to the diagram. Now, could you see where is scenario four? The below one, right? Yeah. So that is the scenario four. Uh, it's quite quite challenging. That's what they say. Actually, there is not much of actually benefit comes out. And where is your main bus actually? The feeder is coming through. Where is that? Could you see anywhere the origin starting point? Zero, and there any node called zero on the top. Oh, okay, so that is the place actually. So isn't it? So I think so. These are the only case I could identify is that the region one is the best one, and then region two, and then region three, and the region four. I think region four probably may not be able to impact much even by using switches. That's what I could see from here. Am I right? So hence of low importance as for the optimization. If you have a couple of reclosures, it is preferred to put it in region one, region two, three, and then region four. That's what they're saying. Am I right? If you have, let's say, two reclosures with you, and if you like to optimally utilize, you prefer to go for area one or two. Good. So now moving to a bit of microphasor measurement units. Most of you might not have seen mu PMUs, but it's a very small device. Okay, and you can see that those devices are very small. It's basically a sensor-based equipment. Probably you can explore in campus. Do we have a micro PMU? If you get a project, you can buy it. It's around 5 to 7 lakhs only. A small micro PM you can buy, and just for satisfaction you can do it. Okay. So microphasor measurement unit. Why don't you ask for two microphasoring PMUs for the department? You see, you have to invest money, no? Huh? I think you asked for two micro PMUs, huh? Okay. Next. So how reliability improves? Real-time monitoring. Micro PMUs provide synchronized GPS time-stamped measurement, 60 samples per second of voltage, current, and frequency, enabling precise fault detection and localization. So that means if there is a fault, your micro PMU can let you know there is a fault occurred. That is what the beauty of this device. And renewable grid visibility. Operators gain granular insight into power quality issues, voltage sag, phase imbalances before they escalate to any outages. Now, renewable integration, PMUs stabilize grid with higher PR penetration by monitoring intermittent generation and adjusting control dynamically. So it has many applications basically. Finally, enables autonomous grid adjustment, reducing manual intervention and outages risk. Okay, the configuration hypothetical scheme of PMU-based protection for distribution system with a microgrid. How people use it's a very costly device. Normally, we are not supposed to use a micro PMU for fault protection or identification. But if you have a device, you can use it. So this is one of the action that the device can take. Now moving to distributed generations, probably we need not waste a lot of time here. We know much about distributed generation as of now, and different type of generations with you. First is localized supply, when you have distributed generations and they are being placed at different levels of your distribution grid, like solar PV, wind turbines, diesel generator, near load centers provide backup power during upstream outages. Means high voltage outages will not affect your supply in the low voltage subject to you have distributed generation in low voltage level. Is it okay? And loss reduction, naturally the loss will be reduced. You know why the loss will be reduced? By having distributed generation? Because long travel of power will not take place. So instead of getting from Kota, if I get the power from MNIT campus, so then my losses also will reduce. And then microgrid support, DGs enable islanded operation during grid failure, yes, ensuring continuous supply to critical loads. Okay, if you have distributed generations, then only you can isolate from the main grid as and when required. Good. So then what about energy storage system? This is also very common. We understood the basic. So if you have a PV based grid supply system and if you have a battery, then you can charge your battery and rest you can supply to the grid. And as and when the load is required, you can discharge from the battery. So first of all, there is a backup power. Battery supply critical load during outages, bridging gaps until grid/DG power resumes. Peak savings, ESS reduces feeder congestion during high demand, preventing overload-induced failures. Okay, so renewable smoothing, ESS mitigates solar wind. We know what is smoothing? Um, because when you have intermittent supply, the supply will be fluctuating. Please try to understand. So because of the battery, because if I get the fluctuation of power, if I get, it's not going to help me. Right? The solar panel will not be producing very constant power. So how do I make constant? To fill the gap, which is known as smoothing. Okay. So my battery will keep on supplying as and when. Okay, it's 20, 0. 19, 1. 21, observe 1. So the battery will help you to get 20 kilowatt supply all the time. So for that, actually, I have to design a controller for my battery to follow and do the smoothing process. Okay, so that is known as renewable smoothing. Okay, and perhaps our admired lab ABB battery is currently operating with renewable smoothing technology. Actually, all right. So impact combined with DGs, ESS can reduce ENS expected energy not supplied by 25 to 40%. Now, maintenance, that is very well understood. I mean, maintenance policy, which is performance-based regulation, corrective maintenance, preventive maintenance, and finally, the customer outage cost and budget availability. So there is no end to that. As we learned, very difficult to make any system 100% reliable, which is close to 20 billion euro for Germany, a small distribution system, am I right? So I think that we learned in the past. So very difficult, but at least a good maintenance approach can improve your reliability for no doubt. Now there are different type of methods available for my maintenance approach. The state Markov model approach, and then we can have actually optimization formulation models. And there are different solution approaches. As I told you, you can use forward backwards with load flow with the binary variables using genetic algorithms. And that is how actually bus 4 of Roy Barrington test system for reliability, very popular in masters you must have studied. Have you studied a little bit of reliability in your past? No. Reliability, no? Okay, so I think reliability is normally it's an elective. I happen to be a bit lucky actually. So I think it's very interesting. So when you get there is a textbook also by Roy Wellington. You can download the soft copy and study, which will help you to understand more about it. Now, what it concludes indirectly, introducing preventive maintenance drastically reduces the customer interruption cost by approximately 73%. Even though preventive maintenance add a new cost of around 2000 USD, it reduces both corrective maintenance and unsupplied energy cost. The total operational cost dropped from 231.19 thousand USD to 72.29. It's basically a significant outcome of a research article. What we want to highlight with those proper approaches, I think the operational cost drops with proper maintenance. That is what actually they're highlighting. Could be interesting, but let us not get into too much detail. Only if you are working in this field, then get into details. This is still continuing. This is still continuing. So the conclusion is if you go for preventive maintenance, though you are investing some money, but in a long run, you will recover multiple times of that. Okay, many times we don't realize that if there is an AC or there is a car, imagine, we don't service it, thinking that actually why do I waste money, it is running. But end of the day, you have to pay much more what you would have paid in the past. Okay, so those who maintain regularly spending 5,000 a year, their car will last actually for longer. Okay, and I am one of those who really normally don't maintain vehicles actually, very regular. Yeah, so so a low budget level, only lines are prioritized. So what you can do, you can say 100 of lines. You say for me this line is important, that line is less important, that line is not at all important. So whenever I like to do bit of maintenance, I see the priority and keep on maintaining one after other. So similarly, the equipments also can be categorized. So line number 6 and line number 27 are never selected due to their minimal outage impact, confirming the model's economy connectivity. Let's say there is a line which is just the end line. I know because of that line, only one customer will be affected. So probably that is my least priority. But if I go to a line through which it will disconnect a street or a colony, so I have to be very careful. Good. So now what we have to do, slowly we'll continue with the a new concept. Okay, so we are done with actually reliability with this. Okay, now we are getting into a distribution system operator, a very, very new topic to all of you. And importantly, you must know why distribution system operator concept is important. Any idea about ISO? Any one of you have heard about ISO? ISO is known as independent system operator. Similarly, DSO is known as distribution system operator. Means they are actually a non-profit organization or an entity which manages load and generation. All right. I will give a little bit idea about transmission level operators. Then I'll come down to distribution sector operators. Now let's say in a transmission system we have 100 of generations and 100 of loads. 100 of generations and 100 of loads. Now all 100 become independent and 100 loads are also independent. How do I balance? Because each and every 5 minutes, the consumers have different requirements. Each and every 5 minutes, I have to instruct my generators to generate in such a manner so that there is a match. How I will do it?
The generations can be aggregated at a point, then can be distributed.
No, but
depending on the
I am a
requirement.
private party. I am not interested to listen to anybody. I may say I am on holiday today. I will not generate any power. What you will do? You cannot force me, no? I am Reliance Power. I am not bound to listen to anybody. So all the generators will decide to go for a holiday today. What will happen? The country become dark. Possible, no? Yeah. So that means not to have that blackout, we need to have a entity who will keep both of them in control. regulatory body, non-profit regulatory body. Very good. So, similarly, in case of, let me explain you a little bit about transmission system so that the moment I come down to distribution system, you all understand very quickly. In the transmission system, what we do, let me assume there are n number of generators and n number of loads. So prior to the real time load and generation matching, real time, I will ask them actually a priori couple of hours before. Please tell me how much energy you like to generate as a generator with what cost. What do you need? You need, I will give you this much of energy and with this cost. Then only I am ready to generate. You have open, you can say 1 lakh per unit to 1 rupee per unit. Everything is okay. Do it. Similarly, we ask the consumers at what price you like to buy the energy and for what block or magnitude. Each and every one in this country, every day, every 15 minutes in India and 5 minutes in US, they actually give their bids. Even today it happens in India. We are simply switching on, the AC is running, we are very happy. It is not so. Just this is how the business happens. Okay. So then what will happen then? So there is no blackboard, otherwise I could have taught. So first of all, actually you give a price. So they in the generator side, we arrange them from the lowest cost to the highest cost. If there are n generators offering a unit price for a block, they will be arranged in a ascending order. Got it? Similarly, for the consumers, there are millions of consumers. Who are the consumer for me? Probably the nearest distribution company is a consumer. That fellow will buy power for me and then supply. So they participate in the bidding process. So the distribution companies also will ask for energy for a block with a price. And they will be arranged in a descending order. Generators will be arranged in
Ascending.
loads will be arranged in, and then first we take the lowest priced generator, and then the next highest, next highest, next highest, lowest price to highest price. And for consumers, we will order from highest to lowest. Why it is so? Because my target is to procure the cheapest power first as a regulator. And my priority is to give energy who is ready to pay more money. He is my priority customer. If you pay more money, you get the first ticket in the airlines. Got it? And then I will slowly clear those. I get 100, I give 100. If that fellow is asking 150, I will take the second one. Give 150, rest is available. Then I'll go to the second customer. So slowly, 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 till the load gets over, all the consumers being given power, then it is going to stop there. Okay, and then few generators will be left out. Few generators will be left out, not to participate in the bidding process. Why? Because they ask too much of money, they become too greedy, so they are not going to participate. So tomorrow what will happen? That fellow will try to bid lower price to survive. So then what will happen? Another medium priced company will go out. So over a period of time, the energy cost will keep on reducing. Keep on reducing. But at the end of the day, the beauty, all of you please try to understand, the moment we stop, where the load is being met by a generator, isn't it? That is the highest cost, the last matching is the highest cost, am I right? And that is known as my actually market clearing cost. So I cannot pay the first one 10 rupees and the last one 100 rupees. It will be cleared at 100. So then I will pay 100 rupees to all the generators scattered power to meet the load. Is it okay? Clear? So I'll just explain you a little bit. So because there is no camera, they may not understand.
Camera direction जो
Not told us actually घुमा दिया this. So what we can do?
इसका direction का तो फिर
No problem, it's okay. Now let's say this is my rupees 10,
roll करो
rupees 20,
पहले सही था पहले
rupees 30, and rupees 40. It's okay. All right. So we now. Yeah.
और थोड़ा सा करो और थोड़ा करो
Board पे focus करिए.
बोर्ड पे और थोड़ा करो हम और टर्न करो
नहीं और थोड़ा सा.
बोर्ड पे करो बोर्ड पे टर्न करो रोटेट पहले जिधर कर रहे थे ना वही
Then the maximum we can rotate. Sorry. Leave it. So what I wanted to say, if we get clear here, then I will pay actually rupees 40 because rupees 10 is not enough to meet my consumers. I go for next generator, third generation, fourth generator, and I realize after taking the power from the fourth generator, the market is being cleared. Means all the consumers have been satisfied. So the cost at which I procured the power from the last generator, that money will be paid to all of them. So this fellow is asking rupees 10, but I will still pay 40. This fellow, because I cannot collect different price from consumers. Because indirectly what happens is he has given a lowest price to me. But when I buy energy from a higher customer, right? So that means I am capable of paying 40, right? So to maintain the market discipline, we pay 40 to everyone. Similarly, when you go for actually those customers actually, those are ready to pay more money. Like the same thing comes here. This is for my
Highest,
consumer. I paid. So whatever the lowest price, I pay, I collect. I will collect from everybody. The same thing. So finally, what will happen? So this is the dotted line. This is the price for all consumers, and this is the price for but no time the independent operator will be the loss. If you see this process, we pay this, for example, at this point, if you land is 20, so this may be let's say 5, 6, 7, 8, whatever it is. So this is one price that comes from consumers, and this price comes from generators. When they cross, you will see all the time that actually the money that I obtain will be higher than the money that I pay. Most of the time you can see the beauty will be, if the characteristic is going to be like this, and if it is going to be like this, where this is my center, and the market is cleared here, for an example. So then what will happen actually, this is the money I collect, and this is the money I pay, and this area will be always slightly higher than this. And that is known as actually the profit, and that name is known as SP, social profit. And that money is again, it's a non-profit organization. So this money will be vested on investment where? Infrastructure for what? No, everything is done. This will be invested on improving the reliability of the system. Could you see the link? So you generate money, that money invest in reliability. So what is the main objective is to make your consumers 100% satisfied and happy. 15 minutes actually start. It depends on how computational strong system we have with us. So it is for 15 minutes. Today it is being for 15 minutes in India. but the target is to go for 5 minutes. Okay, and the moment you make it 1 minute, then it becomes a real time. Okay, means every second you freeze the market. I don't think so we'll be able to do 1 minute so easily, but the target is to go for 5 minutes. That's the future plan. We started with 1 hour, 30 minutes, 15 minutes now. Okay, so it's very interesting. Now the same thing, I can do it for distribution system also. This is currently being operational in case of transmission level. Now at a distribution system, now what happens? My distribution company is X. I'm not taking name like Reliance or Tata or BSC Rajdhani, but there is a distribution company. And within distribution company, there are many users. There is a hospital, there is a five-star hotel, there is a restaurant. And there are different distributed generation companies. Like Manmohan have a PV plant, he has a diesel generator, you have a wind plant, you have a battery. All right. And she likes to buy some power. So there is a market also within distribution system. And the person who manages distribution system and market balancing, and that entity is known as distribution system. Unfortunately, India do not have a DSO as on today. In India, we do not have a single DSO. The first DSO, I mean, we are working in a team where it is expected that we'll bring the first DSO to this country, that is to Delhi market, in next couple of years, but still it is not very certain. However, in Europe, we have actually thousands and thousands of DSOs. Okay, there are a bit of challenges. I will tell you what could be one challenge. If you go for a DSO, because I'm paying money, 50 rupees per unit, let's say, reliability has to be 100%. Reliability has to be. So until unless you are not reliable, how do I negotiate with consumers, Baba? Every day there will be a court case. You took money from me and you could not supply. So first of all, the distribution company must be rest assured they are 100% reliable. Second very important part, the generation available within a distribution system is much more higher than the requirement. Then only the market will be clear, no? If I have 20 megawatt of generation and 70 megawatt of requirement, then what market clear I will do? I will do some forceful clearance, but which is not a good job. Am I right? Only when the generation is more than load, then only this market will clear. It will cross and the market clearing price, MCP, you will get it. Got it? So first of all, and then the very important part, once the important of DSO, once you have a DSO, then you will have an independent system operator or a transmission system operator, we can call it as a TSO. So there is a TSO sitting here who clears the market. Then it comes to DSO level. DSO again clears the market. Means a small rooftop solar power generating entity, means you have rooftop PV, you also play in the national market indirectly. And that is known as DSO interactions. Right? So we are just here in the smart grid. Imagine the bigger picture. There will be millions of smart grids, means millions of DSOs. Because once you have a battery, that battery fellow will say, I will sell energy, as and when you ask, but my cost is different. Because I have invested too much. And distribution company will buy, saying that, my dear friend, you be ready. The moment I give an instruction, please give me supply. He will say, okay, sir, I'm waiting for that. Getting clearer? So what we need to do, the concept of distribution system operator DSO, bidding mechanism for DSO, ancillary, first of all, concept of distribution system DSO operator, I have already explained. All right. Then bidding mechanism for DSO, I have explained. It is for transmission, the same thing will be extended to DSO. Ancillary support from distribution grid to transmission network. Ancillary support from distribution grid to transmission network means capacity, voltage, frequency, all these things you have to support. And then transmission and distribution market mechanism, how they are interconnected. And finally, the case study demonstration on transmission, distribution, interaction. And this is a very, very hot topic. 2020, it started actually. And many people are working this field. Many times, I had a dream that, I'll have millions of, assuming I can simulate millions of smart grids. And then how those millions of smart grid can impact my national peak. I told you already. That is nothing but TSO, DSO. Okay. Getting my point? Very good. So now, see, with these examples, now it is clearer. What I'm doing is research is one way, but I must understand the long-term impact, what we are doing, who is the final beneficiary, for what we are doing, how this is really impacting, is it possible in realistic scenario, isn't it? So role of distribution system operator DSO very quickly. So conventional role of DSO, connected and disconnected of DRs. So it can decide whether to get connected or not. Planning, maintenance, management, network, management of supply outages. Due to short of time, I'm not explaining too much in deeper, but I can talk hours and hours in this topic actually. All right. So energy billing only if vertically integrated, and then emerging additional role of DSO, peak load management through DR. All right. It is the distribution system operator will decide how to manage the peak. Network congestion management also will be decided by DSO. How it will decide? How DSO will decide the network congestion? Because the moment it is getting congested, it will tell the consumer when you participate in bidding, it will say he will ask for 1000 megawatt, let's say. It will say no, 650 megawatt, sir. Why? Because of you, my line is getting congested. So there will be a continuous actually load flow mechanism running behind the screen. So you people will be working behind the screen for a DSO. When DSO comes, millions of jobs will also come. Even now also people are working on. Network congestion management, provide reactive power support to TSO. Now my transmission system says, DSO, please give me some reactive power. So the DSO will see to that how maximum reactive power can be extracted from the system. There could be a reactive power market also. That can be, because everyone is operating with P load and PV generation. So who will provide the reactive power? So there will be reactive power market also, and procure voltage support, technical validation for power market. So this is what actually it works, and possible regulatory framework to foster new DSO. So non-firm connection agreement for end consumers. There are few consumers, they say, I do not know how many of you have seen this, like, in Western countries, recently they have started that there are, passages in the airport where only selected vehicles can run. Okay, that means you pay money and have reservation to that pathway. Okay, so you only can ride on that road. So that means you are not really get stuck in traffic. You are let's say, Elon Musk. You start from your home and then you reach to the airport non-stop, isn't it? And similarly, in transmission system also, I can have a corridor dedicated to Taj 5-star hotel, where I will say, don't worry, sir, all the time the power will come to you, dedicated lines. Is it okay? If you go to Denmark, you'll see there is a dedicated line for cycles. And if you go to Pune, you'll find a dedicated road for government buses. But even private people get into that, nobody respects the rules actually properly. But the mechanism we are trying to implement in this country.
High speed buses, अलग से corridor.
It's working. Nobody go there to that road. They go. They are not supposed to go. Yeah, correct. So what I wanted to highlight, so non-firm connections and firm connections, and finally bilateral flexible contracts. Means it may so happen there is a generator and there is a consumer. What I told you that you participate in the bidding mechanism and the market will be resolved. It may also so happen that I talk to, because you are a company, I am a consumer, we too can have an agreement that you give me energy directly and I will pay you money. And you too can have another mechanism. Or she can have actually, we 5 are consumers and she is generating company, she can sell to all of us. So we don't come into the embed of DSO. They said that is known as bilateral contract. But you will be using the network of the distribution system. You cannot have your own network. So for that, you have to pay some money. How do I calculate how much you have to pay for using that network? Understood? Is it not too complicated now? And that is known as distribution network pricing. In 2005 and 6, if you read all my research papers, there are 3 IEEE transactions on power system where I have explained how to calculate distribution network pricing. And the money that we pay again will be utilized for the reinforcement of the distribution network. Even for a generation company, they have to pay power because they have to evacuate their energy. A consumer also have to pay money to the distribution company because it has to evacuate. And in India, those who look after those distribution pricing mechanism is known as SERB, State Electricity Regulatory Commission, SERC. In Rajasthan, you have a Rajasthan State Electricity Regulatory Commission, SERC, yeah. Right? So all the mechanisms are still in place, but being an end user, we are just concerned whether the light is on or off. We don't understand the whole business model, what is happening. There are local markets also. Good. So what are the key benefits of a DSO? Leverage data to increase RE penetration. If you do that, then naturally there is a competition, people will invest money, people will participate in a market. So, and then increase flexibility in distribution network. It will increase a lot of flexibility, means, it's become very volatile market, okay, and reduce network investment using DRs. When many DRs comes to action, then I need not put more lines because I do not know how do you know this. Now, when you, like Zomato, you give a lot of services, okay? If there is only one restaurant, then actually everyone has to go there and get their food. Now they've created 100 of restaurants. So that means even you do not know that the restaurant from which you are ordering, probably your next door. Am I right? The chain could be here also. A cloud kitchen, probably. Am I right? So by which actually my lot of petrol got saved. The same thing, reduce network investment using DRs. If you have many number of DRs, you need not create new infrastructures unnecessarily. So DSO could procure flexibility services such as voltage support, congestion management, peak saving from the DRs that are already connected to their DN distribution network, facilitating in integration of REs. It may be achieved through the introduction of locational price signal in the distribution network or the establishment of local market. Bilateral contracts are a short-term solutions and are easier to implement with limited market participation. Now, there is one interesting thing. Let's say there are there is a bilateral contract. Am I right? And this fellow is selling, this fellow is buying. How much money they have to pay to the distribution network? 10 kilowatt injected, 10 kilowatt drawn. So, who will pay for the distribution losses, my dear?
So the power input and output is same, then
Because when you say contract, I'm asking for 10 megawatts, so she will give 10 megawatt and rest. I will take 10 megawatt and rest. Who will bear the distribution losses?
consumer.
No, but now I'm drawing 10, no. So losses kahan se aayega actually? Consumer will bear, but you must know how much, no?
We have to take more power, we have to calculate.
You have to run the distribution load flow without this bilateral contract. And by putting this bilateral contract in place, you have to calculate the distribution losses. That will be slightly more. And that losses will be charged either to the generation or to the consumer or half of whatever it is. Got it? And then there is a concept called LMP, locational marginal pricing. So you'll come to know for at a particular location for injecting 1 megawatt of power, what would be the cost of that energy? Jaipur energy cost is different than Bombay cost. No? Why it is so? Because if I draw or inject 1 megawatt in Jaipur, if I draw and inject 1 megawatt in Mumbai, the cost to the transmission system will be different. That is known as LMP, location of marginal price. So based on that, actually, you can calculate the energy cost at the drawing point as well as at the injection. So based on that cost multiplied by 10 will be collected from this fellow. Based upon that unit cost multiplied by 10 will be charged to that fellow. So that you get X, you pay Y, and X minus Y will be the cost given to the distribution system operator, for which the network. What that money, the distribution operator, what he'll do with that money that he has taken from us?
Reliability.
No. Reliability is different. That social benefit, दान करने वाले reliability करेंगे. You know. When I own a distribution system, that means for running this system for 1 year, I have to invest some money. No? And that money I will take from bank. So whatever I collect, actually, I will pay the EMI for that actually. Isn't it? Because transformer hook jayega, I have to repair, no? Who will pay money to that? So I'll take 1 billion from the American bank, invest it, collect this money and pay and make little profit out of it. So the extra revenue stream for providing these flexibility services would incentivize the owners of the DRs to further deeply deploy those these resources, which in turn increase the flexibility in distribution network. So what it means that, distribution network facilities, infrastructures, generators, DGs, they can also earn a bit of money depending upon the timing, etc. But currently what is being done? You pay the energy to the distribution company by putting rooftop, and that is being deducted from your consumption. But if you're going for a holiday for 3 months, then you do not know how much you are getting for that. You are not being well paid, They will give you some discount, 50 rupees per month, because they feel, I'm not interested to take your power as though it is going waste and I am utilized. And perhaps they'll penalize, sir, you have connected to my grid and you pay me 100 rupees per month. So there is no flexibility market. So I think you have to motivate and engage people in this direction. Using DRs to reduce network investment, which is very clear, we have already discussed. And leveraging data to increase renewable penetration. Because, sir, if you have a EV and you put V2 grid, then can we earn money? Oh, yes, why not? If I think, who is this gentleman? Ankit. Aniket. Aniket, yes, Aniket. I mean, it is possible, but until unless you have a distribution system market in place, once you have a DSO, probably, you can certainly get some benefit out of it. I do not know as an individual car, but you can join a small parking lot where this can be given. Yeah, I think it is possible practically. So DSOs can serve. Okay, thank you. All right. So DSOs can serve as the central hub for managing consumer data related to electricity consumption, production, billing, and location, as well as the type of DRs. So basically, whenever you have DRs in place, belongs to consumers, and you have to balance it out, the load and generation, and the rest will come from the main grid. So you need a distributed system operator, DSO, to manage such markets. Now, what are the key factors to enable deployment of such regulatory framework for the future role of DSO? And standards for data management, smart grid and digital technologies, improving communication with consumer. So end of the day, what we are concluding, all these factors are part of my smart grid. So the moment you move to a smart grid, that means you are closely approaching towards a distribution system operator mechanism. Right? So this is what actually the country is eyeing for actually. So key factors emerging role of the DSO, if you can say, key countries incentivizing the expanded role of DSOs, countries in European Union and United States, they incentivize DSOs, those are operating smartly. What are the key transformational steps being taken by DSO? Deployment of smart meters, naturally, because when you say DSO means everything is perfect, digital, real-time monitoring systems, creating a level playing field for aggregators. You know what is aggregators? Aggregators means he's like a broker. He do not have any energy with him, but he will sell you energy. इतना स्मार्ट पर्सन देखो, कुछ नहीं उनके पास, बट आपको बिजली बेचेंगे. मतलब they will talk to the generator company, negotiate, 10, 20, 50 देना मेरे को. There's a few businessmen, no, not having grains, but they are selling grains. Just phone पे actually business करते हैं. So aggregators are like this. They will talk to the generators, they will talk to the consumers. मनमोहन कितना चाहिए? 50 किलोवाट. उनसे बात करेंगे, मैडम 50 किलोवाट चाहिए और आपको कनेक्ट कर देंगे. But the advantage of aggregator, there is a benefit also. When you talk to 10 consumers, okay, then your price will go down. Because if you ask someone for energy, he will say 10 rupees. But if an aggregator tells her, I need complete your power, I will buy. You give me 6 rupees, he will say, okay. And he'll sell 8 rupees to you. So you'll go to him, no, and 2 rupees he will earn. Sounds good? Interesting? So that is known as the role of aggregator. So establishing local marketplace, key drivers for the transition, network capacity deferral, and then local congestion management can be done. And the need for the voltage control is possible. So key flexibility service is being procured, demand side response. And that's what the gentleman Aniket was asking, can I give some electricity from my electric vehicle? Yes. You can participate in demand side response mechanism. Synthetic inertia, you can supply power quality issues, congestion management, voltage control, reactive power support. Everything is possible, but everything is in a market form. And then whatever the smart grid control, response mechanism, optimization, people are working, become a very, very important field for a DSO enabled with a smart grid mechanism. Right? Good. So if you see the overall model framework, actually new DSO functions, distribution market operator, DERM, and distribution energy management, long-term planning, short-term planning. Then you can new opportunities, could be new innovations, then monetization, how can you make new business models, and consumers and producers empowerment is possible. Greater efficiency and optimization, greater reliability, cheap electricity cost. At the end of the day, we expect more cheaper and more reliable electricity. That is what we want. And new energy economy is going to be the ultimate goal of this business. Now moving to DSO coordinator, the question comes why it is necessary to connect DSOs and DSOs together. All right. So as I told you that because the TSO, because there is a market in DSO, there is a market in DSO. The TSO market can be cleared only when the DSO market is cleared properly. And they can complement to the TSO operation. For example, service procured by transmission system operated TSO are being provided through DR, typically connected to medium voltage and low voltage distribution networks. Due to the relative scarcity of DR today, this procurement is done with the assumption that DS are fully capable of dealing with the resulting time varying power flow. Given the rising adoption of PV and BSS, which offer significant controllability, the level of services that can be provided by prosumers is rapidly increasing. In distribution system, large penetration of DR alone can cause technical problems and challenges due to reverse power flow, such as network asset congestion and voltage excursions. these issues can further, exacerbate or complicated when controllable DR such as BESS participation in the provision of services. So it is basically a complementary mechanism. You instead of considering it as a simple load at the distribution system, transmission system see distribution system as a load. But now it sees a distribution system load become a flexible one. There is a market. So based on the instruction coming from the transmission will be adopted by the distribution system. Now let's say transmission system says, I have to curtail 10% of load. So immediately the DSO will also curtail 10% of load. So there is a great match. Imagine the distribution network renewable generation is more than the consumers now. You have enough DGs. So now what will happen? The energy will flow reverse from 33 kV to 132 kV to 230 kV. So that time actually the TSO will reduce buying the power from the transmission systems. Are you getting my point? That is how the TSO-DSO interaction mechanism. Or imagine TSO has actually a lot of excess energy. So it will say ki sasta ho gaya energy, le lo. So then the DSO will try to motivate people to consume more power with cheaper cost. I think that is how the system works on actually. So TSO-DSO interaction become very, very important. So these issues can be further complicated when controllable DR such as BESS participate in the provision of services. And in some countries like Australia, firm limit on DR exports are being imposed to help the deal with these issues. Sometimes, there are restrictions that you cannot sell beyond a particular power. Each consumer can sell only up to a particular limit. To have an idea how much of renewable is being penetrated to distribution system. Otherwise, you do not know how much will come to you and how to protect them. So while this could be a viable intermediate solution that allows DR participation in the provision of services and satisfying network constraints, such traditional fit and forget approaches could also prove to be too prohibitive in the provision of services, effectively limiting the attractiveness of DR providing services through distribution networks. In the last few years, an alternative for countries, regions with open market is for distribution companies to have an active role in managing DR services. Example, energy for balancing purposes, ancillary services, demand response, etc., provided directly by consumers or via aggregators, whilst also incorporating network constraints. The new role is commonly associated with the term distribution system operator DSO and has a objective to efficient facilitation of DR services by making the most of the existing infrastructure without compromising distribution network integrity. So the idea is how to utilize maximum renewable energy with the existing network or the system available to me. Given that DSOs will inherently affect the way DR services will be provided, this new environment requires a paradigm shift in the way the transmission distribution system interact. Consequently, having an adequate TSO-DSO coordination becomes crucial to ensure not only that the DSO role is fulfilled, but also the efficient operation of the power system is possible. Got it? So imagine how big the scenario now. So with a smart grid become very, very small now, isn't it? There is a bigger aspect actually of a smart grid. Thank you very much. So today's talk is actually a little bit interesting. So please go through the whole study. It's a new for most of you. We have never studied about it in our past until unless you are working on a particular topic and doing research in this field. So with this note, thank you very much. And please let me know if you have any doubt through email. Thank you. Thank you. Now, any questions? We can take a couple of questions, at least 2-3 questions. Please. Another question?
No, sir.
No question? Very good. So probably they understood because we went very slow.
Sir, can you suggest any reference book for study? Reliability पे सर कोई book आप बताएं थे?
Tell me.
Book on reliability.
Book DSO?
DSO or maybe reliable.
I think at this point of time it is research articles only. But we'll try to help you with some textbooks. Okay, maybe due course of time and more, you can search and suggest some economical textbook.
Any book for reliability?
Sir, reliability under power quality? No. Reliability is different, power quality is different. Reliability means infrastructure compatibility for assured power supply. Okay. Actually, probably I can say power quality is part of reliability. Isn't it? Other way around, actually, if your reliable power supply is possible with good quality of power, actually. Isn't it?
So in the last semester, we had visited SNDC here. They were also saying that every 15 minutes they take like how much energy they have to dispatch. So the same thing is done by distributed system operator in the near future.
SLDC is slightly a different mechanism. SLDC has a different role. They also know they receive instructions and supply. But SLDCs are basically participate in the overall thing actually. But today, if you see, very interesting, out of 100% energy, only 5% participate in this market. Still 95% of people do not participate in the market. You tell me why? Because there are fixed transactions. Means people know that nuclear power plant of quota will generate this much and will go to a particular transmission grid. So most of the government entities are not market driven. Okay, I think probably it will slowly increase actually 5% to 10%, but that itself is 50 gigawatt market. It's not an easy thing, And I think slowly next 10 to 20 years time, probably everything will be more market oriented. Yeah. Thank you. Thank you very much. You can close up now.